And our next topic is differentiability. And if you remember, you have already learned about the derivatives in your previous class. And if you remember, the derivative of a function f at point C is defined by limit h approaches 0 f of c plus h minus f of c upon h, provided this limit exists. And also remember, derivative of f at the point C is denoted by f dash c, and it is also called as the derivative of f with respect to x, and is equal to f dash x is equal to limit h approaches 0 f of x plus h minus f of x upon h. But this is, of course, under the condition that wherever the limit exists, and it is called as the derivative of the function f of x at the point x, and it is called as derivative of function f. And this derivative of f is denoted by f dash x, or we also write it as derivative of f of x with respect to x. Or you can say if y is equal to f of x, then the derivative can be also written as dy upon dx, or simply as y dash. And now this process of finding the derivative of a function is called as differentiation. We also call it as the differentiation of f of x with respect to x, and we denote it by f dash of x. And in the previous classes, you also learnt about the algebra of derivatives, and as per which the derivative of sum of two functions is equal to the sum of their derivatives. And similarly, the derivative of difference of two functions is equal to the difference of their derivatives. So if u and v are two functions, then the derivative of u plus v is equal to derivative of u plus derivative of v. And similarly, derivative of u minus v is equal to derivative of u minus derivative of v. And in the previous class, you also learnt about the product rule of derivatives, as per which if u and v are two functions, then the derivative of product of u and v, or u and v dash, is equal to derivative of u into the function v plus the function u into derivative of v. And also there is one more rule which is called as the quotient rule. And as per this rule, if u and v are two functions, then the derivative of quotient of u and v, or u upon v, is equal to derivative of u into the function v minus the function u into derivative of v divided by square of the second function v. But here we must make sure that the function v is not equal to 0. So now in the process of differentiation, we shall be often making use of these product rules, the rule of sum and the quotient rule. And just to recapitulate and as a quick add to your memory, here are the derivatives of some of the important functions which you learnt in your previous classes. And the first function is x to the power n. Now if f of x is equal to x to the power n, then its derivative is given by n into x to the power n minus 1. Similarly, derivative of sin x is cos of x, and the derivative of cos x is minus sin x. And similarly, the derivative of tan x is secant square x. And if you remember, the derivative of cot x is minus cosecant square x. And what's the derivative of a to the power x? Again, if you remember, the derivative of a to the power x with respect to x is equal to a to the power x into log of a for the base e, provided a is greater than 0. And what's the derivative of log of x with a as its base? Again, if you remember, its derivative is equal to 1 upon x into log of a to the base e, where a is greater than 0 and a is not equal to 1. And what's the derivative of e to the power x? Again, if you remember, the derivative of e to the power x is also equal to e to the power x. And what's the derivative of log of x? Now, the derivative of log of x to the base e is equal to 1 upon x. And also, what's the derivative of secant of x? The derivative of secant x is equal to, you have learned in the previous class that derivative of secant x is equal to secant of x into tangent of x. Similarly, the derivative of cosecant x is equal to minus cosecant x into cot of x. And now, apart from the rules of derivatives, we shall also be making use of the limits of some important function which you also learnt in the previous class. And if you remember, now let's recapitulate few of these limits. And if you remember, limit x approaches a, x to the power n minus a to the power n upon x minus a is equal to n into a to the power n minus 1. And limit x approaches 0, sin x upon x is equal to 1. And also limit x approaches a, sin of x minus a upon x minus a is also equal to 1. And also remember, in the previous class you also learned that limit x approaches 0, tan x upon x is equal to 1. And similarly, limit x approaches a, tan of x minus a upon x minus a is also equal to 1. And the limit x approaches 0, a to power x minus 1 upon x is equal to log of a to the base e, where a is greater than 0 and a is not equal to 1. And also, in the previous class, you also learned that limit x approaches 0, log of 1 plus x to the base e divided by x is equal to 1. And the other important limit which you learned was limit x approaches 0, log of 1 plus x upon x to the base e is equal to log of e to the base a.